Now, what we're going to be doing today is actually probably the most important thing you will learn in the topic, because this sets the foundation for everything else we'll be looking at. Now, what we are learning about is trigonometric ratios. Now, this kind of comes back to the idea that we are always studying right angle triangles. Okay? They're always the same shape. They always have a right angle, they always have a hypotenuse, and they always have two smaller sides. Now, there is some kind of relationship or some kind of ratio between these triangles, which we can go through, explain, and then we're going to identify them. So, just here, if we have these three triangles, okay, we have 13, 12, 5 as the sides, but if we were to double this triangle and times it by 2, we'd get 26, 24, 10, but they are still the same triangle. Okay, it's just bigger in size. Again, if we were to take this triangle and times it by 3 and make all the sides 3 times as big, so 39, 36, and 15, we can say, okay, well, it's still the same triangle, but it's just bigger. And we're just making it by 2 and by 3 times bigger. Now, what's curious about this is this angle here. In all of these, this angle shouldn't change. This angle will stay the same through all of them. And that is very important, because despite how big the size of the sides are, if they are still within ratio of each other, these angles should always be the same. So we can start to identify, okay, there is a ratio, there is a relationship between the angles and the sides. And we can actually go, okay, how can we start to categorize them? Well, the first thing we have to do is we have to start defining the sides. Okay? We had said previously that the side opposite the right angle is always called the hypotenuse. So we'll call that with H. Okay? Similar to this. Now, we are also going to define the other two shorter sides. We are going to say, okay, the side opposite our angle, which I'll name in a second, if we have an angle, the opposite side, we're going to call the opposite. And the side next to, we're going to call adjacent. So adjacent means next to. Now, what is going to be a little bit confusing about this, and I'm going to explain very quickly, very poorly triangle, if we have our angle up here, here's our angle, we have this as our right angle, the opposite side would be our hypotenuse, and the opposite side to our angle is always called the opposite. And the side next to is called the adjacent. What we can see here is the difference between this triangle and this triangle is that the hypotenuse is still the same. It's still opposite the right angle, but the opposite have changed and the adjacent have changed. They've switched places. The reason for this is because where we name these, or where we place these, is based on where our angle is. Okay, so everything has to be measured from the angle. So we have these definitions of the side next to the angle and the side opposite the angle, but we have to know the location of the angle within the triangle first before we start labeling them. So some students think, oh, this is always the adjacent, this is always the opposite. No, that's not the case. This would always be the hypotenuse because it's opposite the right angle, but the adjacent and opposite can change places depending on where your angle is going to be located. And that's very important. Now, we're actually going to name our angle. We've been using this little symbol, and we call this little symbol theta. It's a Greek letter, and it's just used for the unknown angle. So just like how we use x in algebra for an unknown number, we're going to use theta for an unknown angle. And that's just the symbol that we're doing. If you're finding it hard to draw, it's just a circle with a little kind of loop in it, a little line in it. So, basically, we're explaining this, how angles, our adjacent and opposite can change places where our theta is located. Okay, now it comes down to the actual learning of the trigonometric ratios. So we established before with those triangles, there is some kind of relationship and ratio between the angle and the sides, despite how long they are. If they are all within ratio, the angle should stay the same. So we're going to use that ratio and this definition of opposite, adjacent, and hypotenuse sides to establish these three trigonometric ratios. Now these are very important and you must just tattoo this on your book somewhere because you will continuously come back to this. This is your new kind of ruler for measuring everything and figuring everything out. Okay? So for a right angle triangle with the given angle of theta, the three ratios, sine, spelt sin but pronounced sine, cosine, pronounced cos, and tangent, pronounced as tan, are given by this. So sine ratio, cosine ratio, and tan ratio. Okay, let's go through this slowly, and I'll come up with a picture to make sure you understand. Sine theta is the length of the opposite over the length of the hypotenuse. Okay, so it is very, very helpful to have a triangle. Let's draw a triangle, and let's actually give it some numbers to help us along the way. So we'll say this is 3, this is 4, and this is 5. And let's do our theta, our unknown angle, in this corner. Now, if we are trying to find, and we're just trying to find sine, cos, and tan, and we're doing baby steps for now, some of you might ask, how do we actually compute it? We are not going to compute it today, we're going to compute it tomorrow. How to find the side, the angle of these given ratios. But if I'm asked in this triangle, I want to find sine theta, okay? Sine theta. And this equals the length of the opposite side over the length of the hypotenuse, okay? So before we even start doing that, we should define what our hypotenuse is. Well, our hypotenuse is opposite our right angle, so this is our hypotenuse. Our hypotenuse equals 5. Our opposite from our angle theta is 3, so we'll say that's our opposite. So opposite equals 3, and our adjacent side equals 4. Okay. So let's go through this. The length of the opposite side. Well, the length here is 3 over, this means a fraction by the way, the length of the hypotenuse. So 3 over 5, sorry, which is 3 over 5. And this is our sine theta ratio, just here. Okay? So if we were to double these or triple them, they would still simplify to 3 over 5. And that's all you need to do. Okay? If we're doing our cos theta is the length of the adjacent side over the length of the hypotenuse. Well, our adjacent side is 4, and our hypotenuse is 5. Okay? Now, what you've probably noticed about these first two, sine and cos, is that they are both over the hypotenuse. Okay? So one is going to be the opposite of hypotenuse, the other one's going to be adjacent over hypotenuse. What about tan? What happens there? This is where students get a little unstuck, because tan theta, draw a line here, is the opposite over the adjacent. Okay, so the length of the opposite over the length of the adjacent. So the length of the opposite is 3, and the length of the adjacent is 4. So these two are quite easy because they're both of the hypotenuse. This one's a little bit confusing because one was like, oh, is the opposite on top or the adjacent on top? And we're going to come up with a little trick in a moment how to remember that. So this is going to move us on to our next section. But the most important thing is that you write this down and you do a big red box around each one of these, because this just here is the most important thing you will learn in this topic. and we'll continuously come back to this, and it is now assumed knowledge. But that's a lot to take in, okay? And it's probably a bit daunting, but we've come up with an easy way of remembering it. Okay, so sometimes that is a little hard to remember. So we've come up with this little easy way, which is so, ka, toa. Now, you might have heard this before, and it's just a shorthand of all those trig ratios we just learnt. It is sine, opposite over hypotenuse, cos, adjacent over hypotenuse, tan, opposite over adjacent. So it's just taking what we just learned, all these big concepts, and just boiling it into 9 little letters. And it's a very, very helpful way of remembering it. So this is my big tip. Okay? Whenever you're about to start an exercise or an activity, so if you're labeling your work, let's say this is exercise 3C, and you're labeling it at the top, I would actually write this at the top as well. So so, ka, toa. Okay? And you will continuously just come back to this. Rather than flicking through your rule book or looking them up, you can just have this at the top of your page, and you'll always refer to it. Okay? So so, ka, toa. Or as my last year 9s said it, they said suck a toe. That does not help. So, ka, toa. So, let's do some questions, and we're just putting them into those ratios. So, copy this triangle and label the sides as opposite to theta, adjacent, and hypotenuse. Okay, so here's our triangle. Now we know that opposite the right angle is going to be our hypotenuse. So that's our h. It's an ugly h. Let's redraw that again. The side opposite our theta is going to be called our opposite, so O. And the side next to our angle that isn't the hypotenuse is our adjacent. Easy. Okay. Using the given sides, write the trigonometric ratio in fraction form for each of the following triangles. Okay. So, again, I am going to write so, ka, toa. Okay, and that's going to help me solve these questions. So, looking at this, I have got this angle, I have got the side next to, so I know that's an adjacent. I've got the longer side, which is opposite my right angle, and I know that's my hypotenuse. I'm like, okay, those are the only 2 sides I've got. I've actually got to use this suck a toa to figure out which trig ratio it's going to be, sine, cos, or tan. Now, which trig ratio has an A and a H in it, an adjacent and a hypotenuse? Well, it's going to be this one, the C. And this C stands for cos. So I'm like, okay, the way I'm going to write it out is cos theta equals, now for this it is adjacent over hypotenuse. So the rule is already here, cos adjacent over hypotenuse. So my adjacent is 5 and my hypotenuse is 7. And that's all I have to do. Okay? There's no mathematics involved, there's no moving around, it is just categorizing these into the correct trig ratio and writing the right sides, or the right measurements, over each other. So just using this, that is today's focus, is just making sure you're very familiar with this. Okay, let's look at this triangle. I've got my theta, my unknown angle. I have my opposite side, which is 4. The side opposite the right angle and the longer side is my hypotenuse. The trig ratio that is going to have an O and a H here. That has an O but no H, that has an H but no O, this has an O and a H in it. So opposite over hypotenuse. So this S stands for sine. So I'm going to use sine, spelled sin, pronounced sine, and it's opposite over hypotenuse, 4 over 9. That's it. That's all I have to do. This will get a bit tricky to get the hang of, but once you've mastered it, it's quite easy. You've just got to use this. And the last thing, we've got this angle, we've got an opposite, which is 3, a side next to was an adjacent. Well, if this is sine, this is cos, this is going to be tan, obviously, because I've got an opposite and an adjacent, opposite and adjacent. So this is going to be my tan theta. And my opposite is over my adjacent. So my 3 is over my 5. And that's it. That's all you have to do. So the main focus, the most important thing I want you to take away and master this lesson is just using this. Okay? Even if you didn't quite understand all the ratios at the start, stuff like looking at all the different types of triangles, what I really just want you to make sure is that you can master these 9 letters and by using them. Okay? Because that's going to keep coming up over and over again in this topic and throughout all of your mathematics at high school, even into year 11 and 12. So this is very important that you do it correctly. So please take your time in doing these questions. If you get something wrong, actually go back and fix it, because the hard work you put in now will help later on.